Good morning or good afternoon. Welcome back to another Provident webinar. Usually you have Chief Ed Man giving this introduction, but he is currently having a little computer technical issue, so he will be back. But I will be just doing the intro until I can introduce our friends from Coldcut Systems. So my name is Sam Tellerico. I'm the marketing director here at Provident, and I'm usually always behind the scenes for these webinars. And I help to get people such as yourself to register and join us. So thank you very much. So we're excited to introduce two special guests from Europe. Today we are joined by Lena Håkansson and Carl Batchelor from coldcut Systems. And Lena and Carl will introduce themselves to you shortly. We have done at least 4 webinars in the last year related to electric vehicles and lithium-ion batteries. And several months ago, Martin Orman and Chief Mann started to have conversations with one another that ultimately led to today's webinar. So we're excited to gain some insight from our friends in Europe about the tools and tactics used in their countries to deal with lithium-ion batteries and vehicle fires. And Ed has, in his past, he spent 4 years at the RAF Alconbury in the UK as an Air Force firefighter. So he had the opportunity to gain some really great insight into the fire service in Europe, which hopefully when he joins again, maybe he'll talk about that closer to the end of the podcast, or excuse me, this webinar. So very quickly, as we always do in the beginning of these webinars, I'm just going to share my screen. And we're going to do a quick conversation about what Provident is, and then we can go right into introducing our friends. So what is Provident? So we are an insurance company. We started as an independent insurance agency in 1902. In 1928, we began serving volunteer fire departments with a customized A&H policy. And today we do a multitude of programs for firefighters, EMTs, law enforcement, and we have a special risk program as well. Just recently, as in 3 weeks ago, we received for now 7 years in a row as the top insurance, rated a top insurance employer by Insurance Business America magazine. So just a few little quick highlights. So this is our emergency services programs rundown. We have an A&H accident health program. With that comes our first responder assistance program. This is a 24/7 service that you can call, you or your family members can call for any form of assistance that you need. Oh, here's Ed. Okay. That you need in your life. When you call that number or text it, there are mastered level clinicians to help you through all sorts of problems or issues that you're dealing with. So it's a great program that we've had for quite some time now, and that comes with the A&H program. We also have a 24-hour accidental death and dismemberment, group term life, critical illness and cancer, and then our Fire Plus, that's our property and casualty program. And so with that comes the Fire Plus Academy, which, as we see here, has over 800 plus courses that you can use towards your continuing education credits. All right, so we always like to plug our next webinar. I'll put that link in the chat once I'm done talking. But we have an October 29th webinar coming up on family survivors affected by first responder suicide. I mentioned that first responder assistance program that is run by a company called BHS, a company we partner with. And so during this webinar, we're also going to have Abigail Tidwell, who is a counselor at that company, talking more about suicide and how to make sure that you, if that transpires, if someone's talking to you about that, the steps to take in order to help them. So, all right. Today we're so excited to introduce Lena and Carl, panelists from Coldcut Systems. I'm going to stop sharing my screen. I'm going to let them come on, and I'm going to let them introduce themselves and run through their awesome presentation. So, Lena and Carl, thank you so much.
Thank you.
Let me just stop sharing. Okay, you're good to go.
Thank you, Carl. Will you share the screen?
I will. I will.
Perfect.
Bear with me. Where are we? There you go. Do you want to introduce yourself while I'm just trying to share this on the proper page?
Yeah, right. Okay, I can start with presenting myself. My name is Lena Håkansson. I live in Sweden, and I began my firefighting journey as a part-time firefighter in Åre in Sweden. And I really enjoyed being a part of that crew. However, I wanted more, didn't want to stay as a part-time firefighter. And that led me to explore further opportunities, and I discovered the fire protection engineer program. And after I graduated from that program, I spent several years as a fire and risk consultant. But today I work at coldcut systems in method and training development. And my role here allows me to connect with firefighters and understand challenges and explore how a cobra, the cutting extinguisher, can offer solutions to problem areas. And I find it incredibly fulfilling to see ideas come to life, and also hear or get the feedback when cobra has been used in a successful operation, and where cobra actually made a difference. But one of the most exciting aspects of my work as for now is our ongoing research on EV fires and the method that we are going to present later on today. You go ahead, Carl.
Yeah, good morning all to the US market, or good afternoon here in Europe. My name's Carl Batchelor. I spent 32 years as a career firefighter in West Midlands Fire Service, which is one of the largest fire services in the United Kingdom. I was based in a place called West Midlands Fire Service, which is slap bang in the middle of England. I spent a lot of that time, obviously as an operational firefighter, but I also spent a lot of that time in training departments, specifically SCBA, tactical ventilation and fire behaviour, heading up a team of specialists rolling out training to our local firefighters and further afield. As I said, I spent 32 years there. I joined in 1984 and retired in 2016. I then went on to work at the International Fire Training College at Morton-in-the-Marsh in the Cotswolds in England. And we deliver fire training courses to delegates from all over the world. But again, I specialised in ventilation training, SCBA training, and fire behaviour training before moving on to recruit training, training new firefighters. So training civilians to become firefighters, which was really, really exciting and rewarding. I've probably been with coldcut systems now on a permanent basis for a couple of years. And use my experience in planning exercises to arrange demonstrations for new and existing customers and potential customers. We arrange instructor courses and instructor refresher courses, and we support our UK markets and further afield as well. So that's me.
Thank you. Would you try to share your screen again? Can't I see the behind the scenes for now?
You got that, Lena?
Yes, thank you.
Looks good on my end.
Yeah, perfect.
Awesome.
Oh, yes.
I'm trying to skip ahead. There we go. So I'm going to start and I'm going to present some general information about coldcut systems and who we are and what we do. So our vision is a world of safer, cleaner, and more efficient firefighting. Oh, sorry. And the Cobra, the cutting extinguisher, is a Swedish innovation established in 1989. By that time, the company worked with cold cutting in explosive and combustible environments. And as for in the mid-90s, there was an accident with a firefighter falling through the roof when he was making a ventilation hole. And the fire and rescue services in Sweden, also with the Swedish civil contingencies, wanted a better solution to make ventilation holes. So our founder, pictured on the right, Lars G. Larsson, thought that he had the right tool to make a ventilation hole. So he tried the Cobra can pierce every known building materials. He managed to make a hole, but the effect of cooling the fire gases was even better and also shown by accident. So ever since, we have been a firefighting tool, and our major owner is Saab. It's a multinational defense and security company, and also IF Metall, which is the biggest blue-collar union in Sweden. And we're also owned by Lars G. Larsson, the founder, and the employees. Oh, that's two ahead. Sorry. Sorry, what's happening? Here we go. So coldcut systems sells and manufactures the coldcut Cobra, and we've done this for more than 25 years. So we have a lot of experience within the firefighting, and the Cobra is used worldwide, though our main customers are within the fire and rescue services, and up to 90% of our users are within the fire and rescue services. But Cobra is also used in airports and maritime environments, car production, as for in the production, and also where they put together the traction batteries, which we are going to talk more about later on. And Cobra works, it's a tool to cool hot fire gases from the outside of the fire compartment. It's sorry, it does not work. So the ultra high pressure, it's the 4,300 psi's. This combined with the cutting media abrasive makes a quick piercing through all known building materials. And it pierces a very small hole, which allows for no extra oxygen to be added to the fire. And once through, it makes a fine water mist that creates a large effective area that cools the fire gases very efficiently. And I'm sorry for this liters, but Cobra uses only, I think that translates to 15 gallons of water per minute. So you can see down to on the left picture, we have a skid unit, which is mounted into the side locker on a fire truck, a smaller vehicle. It's 3 times 3 feet approximately, and it's easy to install. But we can install it into the side locker of the vehicle, or you can put it onto a pickup truck. We do also have installation kits that you can fit into the fire truck. And the main components of Cobra is the system overview to the right. It's the power source, the number 1. It drives the water pump, number 3, which is fed with water from the water tank, number 2. And the water is then led to the abrasive vessel, number 4. So the abrasive is this cutting media that we need to cut through every known building material. So that water and abrasive mix travels through the hose to the handlands where the cobra is operated, I should say. And number 5 is the control panel where we also can operate the cobra. But mainly we use the control panel for starting the system. And we also have an emergency button. Additional or optional is the number 8, the additive tank. And we also have the, as we say, the MPN, the multi-purpose nozzle, which is used for embers and smaller fires like car fires or trash can fires. It is the pressure is reduced from 4,300 psi to 1,200 psi. And the we have 7.5 gallons per minute of water. So we have 2 different systems. One system that delivers 15 gallons per minute, and we also have a system that delivers 7.5 gallons per minute. Skips 2. We do also have training for our system, and basically it's the Cobra instructor course, where we do trainings for instructors. And when you finalize this training course, you become a certified instructor with the knowledge and ability to train your own crew to be Cobra operators. And after a certain time, you might be, you want a refresher course, a refresher of the instructor training. And also we have a Cobra captain course. We call it the incident commander course. It's more focused on risk assessment and decision making on how or when to use Cobra and why to use Cobra. And then our latest addition is the Cobra and EV battery fire course, where we of course talk about risks regarding EV fires and the potential to use Cobra as a tool to fight these kinds of fires. We do also bespoke trainings for customers who want special training, like the Royal Navy here, where they ask for a certain training, and we customize the training for those. So that was short about the Cobra and coldcut systems. I'm going to give you a brief introduction to how we developed this EV method, and Carl is going to go through the method as a whole later on. I'm going to give you the background of how it all developed. So the market, the demand, there was a demand for new method and tools, because we did not have any proven method on how to stop a propagation in a lithium-ion battery. And there was a lack, and the FRS needed a safe and effective tool to handle this. And we knew there was a lot of scientific studies that confirmed that the only way to stop a propagating lithium-ion battery was to get water inside the battery pack. Though it's hard to find a method to get water inside and to cool the cells in a safe and efficient way. So we thought that maybe Cobra could be the tool to do this. So in 2021, we had initial tests that proved that Cobra could stop propagation by internal cooling. And we did these tests together with MSB and Volvo. And we knew that probably this method is going to work because we know that more than 20 subsequent tests have been done by EV car industry, and they had indicated that they had the same conclusion, that flooding the battery will stop the propagation. And we knew that the test from this pre-study showed us that we had results that encourage more studies to be carried out. And as we see in this graph, that as soon as Cobra is deployed, we reduce the temperature from 2,300 Fahrenheit down to 200 Fahrenheit. And whilst we keep on flooding the battery, we see a decrease in temperature over time. So this was the only thing we needed to know that this is something that we should work more on, and we need more scientific proof to be able to make a method that is safe and efficient for the fire and rescue services. So in September in 2021, the Swedish Civil Contingencies again initiated a project where we were a part of, together with broad expertise. There were battery experts and car manufacturers and coach builders. And the purpose of this project was to find and communicate a method, a scientific proven method on how to extinguish fires in electric vehicles. And we wanted to clarify the risks and explain the phenomena propagation. And the aim of the project was to spread the knowledge and create safety. So this was a bigger project where we had 3 different setups of batteries, the first one being sub-packs, as you see on the upper picture, where there's a pack with 4 modules within, a total of 26 kilowatt hours. We also have a battery pack down to the right with a total of 67 kilowatt hours. And we also did a full-scale testing with a full electrical vehicle with 75 kilowatt hours in the battery pack. We tested both pouch batteries and prismatic. And in every test, we had a state of charge of 100%. And the question was, is it possible to stop the propagation of thermal runaway in a burning lithium-ion battery pack? And can we learn or observe things to predict the fire dynamics? And I should say that the probability, the likelihood of a traction battery catching fire is low. For a single battery cell to enter thermal runaway, it needs to be exposed to either external damage, like mechanical damage or overheating. And alternatively, there would be a design fault that no one would know of. But the structure and the bodywork and the inbuilt protection systems protect a traction battery from potential risks. And a thermal runaway means that the battery cells get too hot and its built-in safety valve is activated. And this can lead to the heating of neighboring battery, but it might as well stop there. So a thermal runaway does not necessarily mean that we have a chain reaction, but they could overheat and create this chain reaction. And this chain reaction is known as propagation. And that could also happen from cell to cell, from battery module to battery module, though the car's built-in protection normally manage this. But if not, the heat transfer will occur from battery module to battery module. And the only way to stop an ongoing propagation is by cooling the battery. And that is most efficiently done by establishing an internal flow. And we initiated thermal runaway by heat pads close to the battery cells that would mimic overcharge. So once these are pictures from our first test where we did sub-packs with the 4 modules inside. So we initiated the thermal runaway monitored the battery pack until we saw that the propagation was a fact. And then we started our extinguishing operation. We tried different tools. This is Cobra to try to get to cool the battery packs within the sub pack. We aimed for a temperature to go below 120 Fahrenheit and stay there stable. And once we got the temperature down stable, we decided to end the operation and monitor the battery pack for approximately 15 minutes to make sure that the temperature did not rise again. And all tests, we did 3 tests on this sub pack. All tests showed similar results. When we got water into the pack, we cooled the modules and we could stop the propagation. And the way that we verified that the propagation was stopped was 3 days later when we opened up the battery packs and measured the voltage remaining in each battery module. And as you see to the 3 pictures to the right, you can see that we still have voltage remaining in each battery cell. Those battery modules, involved in the fire have a bit less voltage than those that are not affected from the propagation. So from this, we could conclude that the method of flooding the battery does actually work. But does it work on a bigger scale? So we tried on the battery pack with 24 modules. And as you can see, we have, out of 24 modules, we have 17 modules that were still alive. So to say, they had still voltage remaining. The green ones have still voltage, and hence the red ones are, so to say, dead. One test we did, the total time of intervention was 14 minutes with the Cobra, and the total water consumption was 200 gallons of water. And yet again, we made the conclusion that the method is confirmed, since we did manage to stop the propagation. Though we needed to know if this is an actual feasible method, even when we have the battery pack inside the electric vehicle. Because all of the other tests we did sort of on the surgery table. It was easy to access the battery, and we could angle the Cobra sort of how we wished. But once the traction battery is inside the car, you don't have that many access points. So to confirm that this method can be applied in a safe and efficient way, we tried it in a full-scale EV car. And for this, we initiated the thermal runway. And once we had the first sign that the thermal runway was actually active, we waited for 15 minutes to mimic the time from alarm when somebody would call 911 to the arrival of the FRS. And by that time, we had a full car fire with the traction battery involved. And Cobra was used for a total of 5 minutes, and we used only 63 gallons of water. And simultaneously, while we attacked with Cobra, we used a regular branch to primarily protect the Cobra operator from flames and smoke, but also to extinguish the rest of the car fires with the exterior and the interior plastics burning. The total amount of water used during this intervention was 200 gallons of water, and the total time of extinguishing was 10 minutes. So in this test, we had a total of 27 modules. Out of 22 out of these 27 was still alive, did still have voltage remaining. So yet confirming that this method is working. For all the tests, the subpacks, the battery pack in the full-scale test, we did wait for 3 to 4 days before we opened them up and measured this remaining voltage. And during that time, we lifted the battery packs, rattled it around, trying to provoke a reignition. We never got one, but that is not a guarantee that the battery won't ignite, because it is still unstable. Once damaged or once involved in a fire, there is always a risk of reignition. However, we did not get one in any of our tests. We do know that a propagation can be stopped by flooding the battery pack with water. And that's how the method was developed, and I hand over to Carl to explain more about the method.
Thank you, Lena. Okay, so we've seen the scientific studies that Lena's presented. Now we're going to look at how we actually approach dealing with an EV fire where the battery's gone into thermal runaway, how we approach that from a practical point of view. Not all EV fires will involve the battery being on fire, and not all EV fires where the battery's on fire will involve the vehicle being on fire. Now, most modern EVs we can recognize quite quickly. So we all know what a Prius looks like. We all know what a Tesla looks like. We all know what a Rivian looks like. However, there are a number of cars out there that may be ICE vehicles, so internal combustion engine, or they may be an EV, and they might not be immediately obvious to us. So we might get mobilized to a vehicle fire or a car fire or a truck fire and actually not know it's an EV straight away. So whether or not it's an EV, if the vehicle is involved, we're going to use our traditional methods for dealing with a vehicle fire. So it's inch and 3/4 line and 2 SCBA. We're going to put out the car fire as best we can. What we can't put out is the battery on fire, because the battery is contained within the battery casing itself. The analogy is just like putting water on a roof. Roofs are designed to hold out water. The battery casing is designed to hold out water. So we need to get water inside the battery pack. Once we've confirmed it's an EV fire, and we've confirmed that the battery is involved, and we can tell that by the telltale signs of these sort of low-hanging gases and vapors that are being pushed out from the vents in the battery pack. We may, if we get too close, smell a sweet kind of smell. We may also hear some hissing sound from the gases and vapors being pushed out under pressure. We may also see jet flames coming out of the battery pack. So once we've established the battery pack is involved in fire, or actually off-gassing, we then need to make an intervention onto that battery pack, and we're going to do that with Cobra. A lot of the rescue guides now say get water inside the battery pack. What they don't say is how you can do that. However, Cobra will do that by, as Lena said, piercing through anything. So it'll pierce through the floor of the vehicle, it'll pierce through the top layer of the battery pack, and we can then flow water through the battery pack. We're not going to stop thermal runaway in the individual cell or cells that have started the fire. What we are trying to do that, and what we will do, is stop the propagation. So we'll stop that propagation from cell to cell or from module to module, because we're going to reduce the temperature in there significantly by flowing water through that battery pack. If you imagine your battery pack is like a very shallow bathtub, all I'm doing is filling up the bathtub just to cool it down, to stop propagation taking place. I'm not trying to stop thermal runaway in that cell, just stop propagation taking place. And what we did in the test, as Lena said, we monitored the batteries afterwards for 15 or 20 minutes, and we didn't get any rise in temperature at all. The key number we're looking at is 120 degrees Fahrenheit. Once we've hit that temperature, so by reducing the temperature inside the battery pack by flowing water through it, we're happy then that propagation has stopped. And I'm fairly happy then that our intervention, and from the tests we've done and the tests that we've done subsequently with some partner agencies, every single one of those has worked, and Cobra has dealt with that battery pack significantly. There's a video now. The tests we did involved a Swedish car manufacturer who we're not allowed to mention. Use your imagination, I'm sure. So we set up a video using a Prius to show the kind of method we're looking at. The video is not perfect, but just watch the video and we can chat about that. First thing we do on the vehicle is our normal intervention. We're going to put the bit edge direct away from the firefighting. Stand up wind where you can. That's what you're looking for there, that hot spot. You only need a 1 degree change in temperature. You don't just have to recognise that change in temperature. You then call in our cobra operator. He'll shoot the cobra through the form of the vehicle. Start to reduce the temperature of the soil. Propagation. Right, scan again with a tip. Okay, I'll just stop the video there. Hopefully, and I know I was talking over the video and none of you could hear what I was saying because the video music was playing in the background. But hopefully you got an idea there of the kind of intervention we're looking at. So your standard sort of SCBA wearer and your 1 3/4 line, bringing them in to deal with a car fire. Cobra is the wrong tool to deal with car fires. People say to us all the time, can you use Cobra to put out a car? You probably could, but it's not the right tool. You've got a lot of tools on your fire truck. Use the right tool for the right job. And in this case, Cobra isn't the right tool for dealing with a car fire. Use what you've been using for many, many years. Put your car out, and whilst you're putting your car out, or when you recognise that that battery is involved, we can then do an intervention on the battery pack with the Cobra lance, getting water flowing through that lance. This one here I'm going to talk about was in January 23. Now, this is the first ever known use case of Cobra on an actual EV fire. Now, this was in Norway, and this was a friend of mine called Håvard. He's a Norwegian firefighter and is also a Cobra senior instructor. They got mobilised to a garage, a workshop. When they arrived about 20 minutes after the call, as you can see from the image, they're not particularly good images, but use your imagination, that the fire was ventilated through the roof. It was well developed. It was a 7-stall sort of lock-up garage, and the middle stalls, 3 of the middle stalls were fully involved in fire, and it had gone through the roof. The incident commander spoke to Håvard and said, "You're a Cobra operator. What do you think?" Oh, well, sorry. When they went inside, they found a vehicle in the corner of the garage, and the vehicle was still on fire, and it was on fire quite severely, and it seemed to have flames coming out of it under pressure, and a lot of gas coming out under pressure. What they realised afterwards that the vehicle was an EV. It was a Renault Zoe. Now, the battery in a Renault Zoe comes up and behind the back seats. Now, fortunately for them, pretty much the whole vehicle had burnt away apart from the battery pack. And they could see at the top of the battery pack on a Renault Zoe, there are 3 expansion or ventilation holes to allow the battery to breathe. When batteries operate, they release pressure, they get warm, and like anything that gets warm, the pressure increases. So in all battery packs or battery modules or cells, there'll be a pressure release point. Now, what Håvard could see on the top of the battery were 3 pressure release points, and they were quite obvious because out the middle hole of the 3, there were jet flames coming out of it. So he said to his incident commander, "I understand Cobra. I understand behaviour of fire. I think we can have an intervention here." So he used Cobra to try and get water through the hole initially, directly into the battery pack. And it worked quite well, But what he thought then, he thought, I'm going to change. And he changed position to lower down to try and get water into the battery pack. Because the flames aren't necessarily where the reaction is taking place. The flames are where the gases and fire are escaping from. The reaction can be taking place anywhere else in that battery pack. So Horvath decided to try and get water into the battery pack, and he did this successfully by piercing lower down with the cobra lance. He changed position a couple of times, and eventually he got the temperature down from 1,400 degrees Fahrenheit to about 150, 160 degrees Fahrenheit after about 4 minutes. He reckons he used about 200 gallons of water, but by his own admission, this was the first time he'd ever used it. By his own admission, he said, if I'd have done it properly and with a little bit more practice, I could have probably put it out with about 60 to 65 gallons. So that was the first ever use, a successful use of cobra used on a EV fire. Bearing in mind, the guy had no policies, no risk assessments, no operating procedures, no practice, no training, but it worked for him. There was another one here. It was a fire in an underground garage in Prague, in the Czech Republic, in Europe. This one was April 23, Jaguar I-Pace with a 90 kilowatt battery. The actual garage was about a minute down the road from the fire station. And they got mobilized to smoke issuing from an underground car park. Now, this vehicle here was in basement level -2, so it's below ground. Now, the issue with this garage, this parking lot, the only access to the parking floors is via a vehicle ramp. Sorry, via a vehicle lift. There's no ramp access at all. The only access is via stairwell for pedestrians. All vehicles have to go in and out via a vehicle lift. After about 7 minutes on scene, they heard a small explosion. They tried to get downstairs, but visibility was virtually zero. But they could see with the thermal image cameras, they'd got a heat signature somewhere in the underfloor garage. They used ventilation fans and the lift shaft to try and clear out the gases and vapors, and this worked well for them. Eventually, they managed to get into the garage, and what they noticed in the underground garage, in the underground parking lot, were about 3 vehicles in there. Fortunately for them, the vehicles were well spaced apart. What they did see was one of those vehicles was Jaguar I-Pace. They knew that to be an EV, and what they saw were flames and gases and vapors being pushed out under pressure from underneath the vehicle. Again, Cobra and EVs was not one of their policies. They hadn't got a risk assessment for it. They hadn't done training on it, but they knew Cobra well. They've been using Cobra a long time. They have Cobra on most of their frontline fire trucks. So they decided to use the Håkansson tool, as you can see there, just to lift up the vehicle to give them a slightly better access. So they used a slightly different approach to the one Horvath did. Horvath was going into the vehicle through the passenger compartment. These guys in the Czech Republic decided they want to try a different approach and go actually direct into the battery from below the vehicle. Again, it works. All we're trying to do is stop that propagation. And yes, some of the water you're going to be putting in will leak out of the small hole you've put in the battery. But just like when you take the plug out of a bathtub, all that water is not going to come out straight away. We're still going to get water flowing through that battery pack to stop propagation. After some time, they used about 2,000 litres of water with Cobra, so they used quite a lot of water, but they hadn't been trained. But what they did do, they checked it with a thermal image camera. The fire was below, and they were using Celsius, so 50 degrees Celsius, about 160 degrees Fahrenheit. They were happy that the fire was out. They were that happy that the fire was out. They put the car on little transport dollies, because what we're trying to avoid is rotating the wheels, because the regenerative braking effect can actually put power back into the battery pack. So without rotating the wheels, by lifting it up, they pushed it into the vehicle lift. The only way of operating the lift was from buttons inside. So they actually put 4 firefighters inside the lift with the vehicle. That's how happy they were that the fire was out. And then took the vehicle up to ground level, pushed the vehicle out into fresh air. Again, another successful intervention using Cobra, and that was in Prague in 23. A more recent one, and I do take a little bit of pride in this one, because Tempe in Arizona, Tempe Fire Department in Arizona bought a couple of Cobra units off us earlier this year. And I went out with a colleague of mine, Fergie, who's I know is watching this presentation. We went out and we trained the Tempe firefighters in how to use Cobra. Now, we trained them specifically at their request about using Cobra on EV fires. But once we started talking to them about how we use Cobra in Europe and the United Kingdom, they were quite intrigued about what else Cobra can do. And I'll come on to that a little bit later. But we showed them the method that we saw earlier. We spoke about the risks, the risk assessments, the various risks, including vapors, explosion risk, toxins, all the kind of risks that we discussed as part of the presentation and on the lesson. And if you look at the picture on the right, you can see you've got flames coming out the bottom of the vehicle. Now, those are the points of least resistance in the battery pack. So the battery pack is off-gassing. It's releasing mainly hydrogen and carbon monoxide, both highly flammable and explosive gases. What I can see there is visible flame. If I can see visible flame, I'm a lot happier than when I can't see visible flame. If you equate it to liquid petroleum LPG cylinder or a gas cylinder, flammable gas cylinder, if the gas is leaking without a flame, that's more of a concern to me than if the gas is leaking and it's on fire. In this case, I can see we've got a fire, so I'm less concerned about a massive explosion, although it's still hugely on my risk radar. What the guys did, following off from their training, they used the Cobra lance. They opened up the doors of the vehicle and they used the Cobra lance through the vehicle floor into the battery pack, filling the battery pack full of water. What they did then wasn't perhaps perfect, and I know they have looked at this with hindsight and probably realised they wouldn't do this again. They thought the vehicle was out. They did use a TIG, but possibly not as good as they should have done. They put the vehicle onto a recovery vehicle, then onto a tow truck. Now, the problem is, as they lifted the vehicle up onto the tow truck, remember we spoke about the bathtub full of water, it emptied the bathtub of water. So that battery pack was then emptied of all the water they put in it to cool it down. So as the tow truck was going back to the depot, the Tesla started to smoke off again. It started to off-gas again. So hastily, they took the Tesla off the tow truck and then spent just another 10 minutes, that's all. So about 80 US gallons, 75 to 80 gallons of water into the battery pack, again with the Cobra, just to put it out. And this time it was put out successfully. And they didn't pick the car up then. They left it on its four wheels. So that bathtub full of water, which contains the battery pack, had the water in, maintaining that cooling effect. Propagation didn't start then. So I think that's a really, really successful intervention for them, a really successful intervention, especially as I think the EV rescue data app for Tesla recommends something like nearly 5,000 gallons of water. And they did it with significantly less than that, because the most of the water we're using on these other solutions is just going down the drain. It's just adding to the pollutant. The other one I'm going to talk about is a fire in the Netherlands in Europe. Now, myself and again Fergie, we did some tests at Schiphol Airport in Amsterdam. And ironically, they were setting fire to two electric vehicles. Both of them were vans. And surprisingly, they looked very much like this one. So we went out about a month prior to the tests to train the Dutch firefighters on how to use Cobra on an EV fire. The battery pack in this particular vehicle sits under the back of the van and slightly under the driver and passenger seat. So we trained the guys a month before the tests. We then went out again to Schiphol Airport. We did the tests, getting both vehicles into thermal runaway, and again using UHPL Cobra, we stopped thermal runaway in the battery pack. Amazingly, what happened about a month later, the crews that we trained to do the tests got mobilized to a vehicle fire. The vehicle fire turned out to be this one here in the picture that you can see in front of you. And it was an electric vehicle, it was an electric van, and pretty much identical to the tests, although not as severely involved with fire as we did during the test. But they had thermal runaway in the battery. And again, they used the techniques that we'd spoken to them about. You can see the PPV fan is in place there, just to try and push the fire gases and vapors away from them. They used Cobra to pierce through the floor of the vehicle, through the top of the battery pack, again, just to flow water through that battery pack, just to stop propagation. Remember, we're not trying to deal with that cell that's in thermal runaway. We're stopping propagation from cell to cell to cell by getting water inside that battery pack. That was a really successful intervention again. This is a video of a small BESS, so battery electric storage system, in a private house in the Czech Republic. Czech Republic, big cobra users, as I said before. What you'll see on the videos, you'll see them getting mobilized to the incident. You'll then see them deploying with a standard SCBA team and a standard hose line, supported with a cobra operator. He's initially putting water onto the BESS from a distance. Once the fire's a little bit more under control, he's actually putting the cobra lance onto the storage system, the electric storage system, to try and get water inside, much in the same principle as we would an EV. So just let's watch the video. Okay, so what you hopefully saw then was with decent flaming combustion within the room that they went into downstairs in that house in the Czech Republic. If I see flames, I'm in a happier place than if I don't see flames. There's obviously less chance of a explosion because I've already got flaming combustion taking place. They tried to make the electric storage system a little bit safer before they moved it outside. And when they moved it outside, what you saw then was them just basically destroying every single module one at a time, just so that there was nothing left of it, so propagation couldn't take place. And then you saw them take out the individual modules and just place them in a bath just to be totally sure. But again, it worked well for them. What we've spoken about so far is Cobra for use with EVs. There's a number of products out there that claim to deal with electric vehicle fires. Our product's been out there for about 20 years doing other stuff. We've now recently found out that actually it is a solution for EV fires. What I'm going to talk about now is the other stuff that it's capable of as well. Now I'm just going to play a short video which just introduces you to Cobra and what it does.
Cobra is a firefighting tool used worldwide for decades. The Cobra is a component-based system that is easy to integrate into fire trucks of all sizes. Beyond municipal fire service use, applications include industries, airports, and maritime departments. Cobra is a firefighting tool that uses a lot less water than other firefighting tools. With Cobra, the firefighter can work from a safer position outside the fire compartment. After finding the hotspots, the Cobra is deployed through the quickest access point. With Cobra training, you learn how to use the tool with the most efficiency. The ultra-high-pressure Cobra lance cuts through any known building material. After piercing the building, the water transforms into a fine water mist. The surface of each droplet cools the fire gases very efficiently, and the high pressure generates a velocity of 200 meters per second by the nozzle, which creates a stirring effect of the fire gases in the room. Significant amounts of steam can be seen, showing the cooling effect of the Cobra deployment. By reducing the heat of the fire gases and creating better visibility, Cobra creates better conditions for the firefighter to enter. They can enter the building with fewer risks and less exposure to harmful gases and particles. Most of the used water evaporates by the heat and leaves the building with very little, if any, water damage or contaminated water runoff that could run into nature and harm the environment.
300 meters per second is 447 miles an hour. That's how fast it comes out of the lance at 4,300 psi. You can see how far the trajectory is. It's ultra fine droplets of water, so therefore has a greater cooling capacity of your standard sort of hose lines or even high pressure hose lines. I'm sure all you firefighters online have seen those images before. So when I joined, it was the fire triangle. Now it's the fire tetrahedron because we've included the chain reaction part of it. And by us dealing with or reducing any one of those sides of that tetrahedron, we can then have an effect on the fire. So traditionally, we put lots of blue stuff on the red stuff. So we put water onto the heat, onto the fuel, which reduces the heat, therefore making that equilateral triangle less equilateral. So therefore, combustion is becoming less efficient. What Cobra does when we use it in a compartment fire, because the expansion ratio of water when it turns to steam is so vast, and the hotter the fire is, the more that increases. So we go from sort of 1,700 times to up to nearly 7,000 times. So 1 gallon of water could become 7,000 gallons of steam, depending on the temperature inside the fire compartment. We're actually also, as well as cooling it, we're replacing the oxygen in the room with water vapor, water mist, steam. Therefore, combustion can't take place. So we're actually hitting that fire tetrahedron in a number of ways. And that works really well for us dealing with the oxygen. Some of the techniques we use in the UK now, we use anti-ventilation. So we'll close the door to a fire compartment whilst we're getting our SCBA wares ready, whilst we're getting our hose lines ready. And that slows down that combustion process just by limiting the oxygen. And that works really well, unless you've got something that produces its own oxygen, of course. Which a lithium-ion battery does when it's on fire. The cathode breaks down, releasing oxygen, which is why I'm sure many of you have seen videos of a Tesla fire or a battery pack fire underwater. And as those gases are being driven off, they're igniting because that chemical chain reaction is happening underwater. It's got all 4 sides of that fire tetrahedron. So by us immersing it in water, doesn't work. Fire blanket on it, doesn't work. We need to get water into that battery pack to stop propagation taking place. This took about 3 minutes. So this is 5 3/4 inches of concrete they went through in Poland. Why did they go through 5 3/4 inches of concrete? No idea, just to prove they could. We wouldn't normally do that. So if we're normally dealing with a fire compartment, as we do in the UK and wider Europe, we'd go through the window frame or the door frame. And the reason for that is we know there's nobody, there's no people or no furniture behind the window frame or the door frame. And it's the point of least resistance. I'm going to go through the thinnest part of the building as I can possibly. But you can see here from the picture on the right that Cobra went through 15 3/4 inches of concrete. And that took about 3 minutes. It does have fantastic cutting capability, just using a very, very fine abrasive mixture. It's like an iron silicate mixture, which is a 5% iron silicate to 95% water into the lance. There's 2 levers on the lance, one for water, one which induces the abrasive as well. Once I've pierced through whatever material I'm piercing through, I can release the abrasive trigger and then just flow water into the fire compartment. This video just makes you think about actually how we approach firefighting traditionally. So traditionally, we either go through the door into the room or through the window. Well, with Cobra, we can change that. The fire compartment becomes a 6-sided box. Not only can I go through the door or the window, I can go through the neighbouring apartments or the neighbour's house or the roof or the basement upwards. You can see from that video there, that's just water mist going in there. That's just the water droplets being produced by the Cobra lance. There's no heat in there at all. So imagine all those tiny, tiny droplets of water being converted into steam and the expansion ratio you're going to get there, how that replaces the oxygen in the room with water mist, reducing the chance of combustion taking place and also having that cooling effect as well. This video is showing you going through about 3 layers of drywall. So it will pierce through the first layer. The jet will sort itself out, go through the second layer. It will then sort itself out, going back to a small jet again. And then once again, ultimately, getting water mist into the fire compartment. You can see through, even through all those layers of drywall, we're still getting a decent water mist being produced in the actual compartment where we want it to. This is a video of a standard sort of demonstration that we do, and we did one of these in Oregon week before last. Virtually identical container loaded with plywood and pallets and some straw at the far end. The bit of wood you can see there on the left-hand side, that's just what we call a sacrificial panel. That saves us having to pierce through the metal door all the time. We can if we want to, but there's no point in peppering the metal door full of holes. We can just go through the sacrificial panel, and when that's pierced enough, we can just change that out, get a fresh one in there. It also means we don't need to use abrasive for training, so that just cuts down wear and tear and cost as well. The temperature you can see on the display is the temperature inside the fire compartment. Now that temperature there equates to about 1,000 degrees Fahrenheit. What you'll see initially when he starts to operate the Cobra lance is splashback, so the water's coming back at him. That only happens very briefly because it's a bit of wood. Once we stop getting that splashback, we know then that the water's going inside the fire compartment. The other thing that confirms that is I'll start to see steam being produced after a couple of seconds. Initially, I'll get some turbulence in there as the room sort of sorts itself out. The door is open as well, so you might get a little bit of oxygen drawn in, but not a lot compared to the amount of steam we're going to produce. The key thing is just keep an eye on the temperature and the colour and the buoyancy of the fire gases. So within about 34, 35 seconds, we drop the temperature down from 1,000 degrees Fahrenheit to less than 100 degrees Fahrenheit from a point of safety outside the fire compartment. That's the key thing there. Historically, when we tip up to a building fire, we're sending firefighters in at 1,300 degrees Fahrenheit. We don't always need to. We can send them in at 185 degrees Fahrenheit when we've had an intervention with Cobra. Safer, cleaner, more efficient for the firefighter. This is a pictogram we used in the UK. So this is our hierarchy controls, and firefighters are quite bad at adapting to this because what we do traditionally, we do the least effective method, which is at the bottom. We put our PPE on our turnout gear and we go in there and we intervene in the fire. What we should be doing is flipping that on its head and using the most effective method, which is eliminating the hazard in the first place. We're losing too many firefighters. There's no excuse for losing firefighters in the line of duty. We need to think about the way we're doing things. So if we can remove the hazard, replace the hazard, isolate people from the hazard, change the way we do things. Two things firefighters don't like: change and the way it is now. And I got that from one of the American colleagues, and it's so true across the world. But we have to have an open mind on how we're dealing with fire nowadays. Another reason for that is because the World Health Organization has categorized our occupation, firefighting now, as a group 1 occupation, which means it is carcinogenic to humans. We probably will get cancer. We're now 4 times more likely to get cancer than the rest of the general public. And that's because of the conditions we are working in regularly. We've recently done a contamination study in Sweden, which shows that our method of using Cobra initially, as you saw on the container below, then ventilating out the residual steam and then making an entry for overhaul significantly reduces the risk of getting cancer and contamination. If we don't get contaminated in the first place, decontamination is less of an issue to us. I know we're all moving to clean cab policy, turnout gear used once, all very, very expensive methods and very expensive to administer. If we can avoid contamination in the first place by thinking about other ways of doing things, it stops that and it saves some money as well. Cobra is not a tool used in isolation, and it's not a tool used for every incident either. It's a tool on the fire truck or a tool in the toolbox. Some incidents you'll go to, you might use it, others it might not be suitable. Now for this incident here, we've got a timber framed building in Sweden, very similar to some of the timber frame buildings in the US. With a naked eye, I can't really see where the fire is. I've got a pretty good idea. I can see some smoke coming out of the building, but using thermography, using my thermal image camera, I can see exactly where I need to pierce with the Cobra lens from outside. It's only going to make it better. It's not going to make it any worse by me introducing water mist into that attic space, into that loft space. It's only going to make it better and safer. Again, here, using it from the basket, again, a Swedish case study that daycare, so a kindergarten, kids daycare place. And you can see from the picture top right, they're using Cobra from the basket there. And they're just piercing through the gable end initially and then through the roof, just to get water into that attic fire from a much safer space than either cutting holes in the roof from above or going in from the loft access hatch below. This is a video of pretty much that, actually. It's on a domestic property, again in Sweden, and this shows well, it's not a simulation, it's a real life training exercise. They lit a small fire in the loft, in an attic space of a detached property. Very quickly, that small fire became a significant fire. There's a video camera pointing up from the second floor level up into the attic. The initial video, I think, shows the fire as being on the left and the lance being on the right. I think that switches around when the video changes to the back of the property. But you can quite obviously see from the video the Cobra lance being used off the cage, off the platform, and the steam being produced again in that attic space. Much, much safer from an external point of view. I think you can see the dramatic effect that Cobra had on that attic space there. Instead of sending firefighters up on the roof or firefighters up through the loft space, it's much safer dealing with that from outside. Yes, we've got to go in afterwards and overhaul, but it's going to be a lot cooler, a lot cleaner, and a lot safer for our firefighters. If we look at this ducting work here, so in a typical sort of industrial unit, we've got a fire in the ducting there. So you've either got access panels, or you're going to have to get a grinder, a disc grinder, to cut away to get your normal hose lines in there. We can see using the thermal imagery on the left-hand side that actually where the lance is piercing now, it's much cooler inside that ducting work. What they need to do now is reposition the lance a bit lower down just to hit that hot spot down there. The same in this one here. So for silo fires, ducting fires, Cobra's a really good solution for any areas where you don't want to or can't send firefighters. We instead of having to cut access holes in a silo, a grain silo, just use Cobra. There's a many ideas of where Cobra can be used that we haven't even thought of yet. And this is one of the ones I hadn't thought of. So this is where Cobra was used for heat shielding. Remember we said that jet is about nearly 200 feet long, that water spray, coming out at 447 miles an hour. So we've got a guy who was stood in between the burning building on the right at the bottom of the picture and the farm building on the left. You can clearly see there's nothing left of the farm building at the bottom of the picture. There was somebody on a Cobra lance operating that Cobra lance as thermal protection, just using that very fine water mist. And again, we're only using either 7.5 or 15 gallons of water per minute, just to protect that building on the left. And I think you'll agree it did a fantastic job of doing that with very little water. So think about the areas where you might struggle for water. Cobra's only using either, depending on which system you use, it's either using 7.5 or 15 gallons a minute. That's all it's using. This is one we learnt about Scotland up in the north of the UK. So Scotland just sits above England in the United Kingdom. They used it for deep-seated peat fires. So they have peat fires that burn underground about 3 feet underground, which are really difficult jobs for us. It normally involves us digging them out, digging down with a spade, a shovel, trying to dig it out, to wash it out. They decided because of the penetrating power of Cobra, that might actually work on deep-seated peat fires. It did, and it worked well. And they use that now, and so do other services across the UK who have a similar kind of issue. This container was inside the warehouse on the right-hand side, and you can see the yellow strap at the bottom. They just pulled the container out. Again, instead of either having to open up the back doors and create a vast amount of mess and more risk to the firefighters, they just use Cobra. You can see the guy on the left with the thermal image camera looking for where the hotspot is. They use Cobra to pierce a small hole, dealing with that container fire from outside the container from a point of safety. Again, using minimal water. We're not going to get the water runoff and contamination that we would normally on that kind of incident. Similar incident here, but this is a container lorry. So this is a lorry in, I think it's in Fergie's County, so Northamptonshire in England. You can see where the paint's been scorched on that container there. So we know exactly where we're going to pierce with the Cobra lens. I'm still going to use my thermography, use my thermal image camera. And again, rather than being able to get in that container, drag everything out, I can make that much safer from the outside of that container using very minimal water and a hole probably somewhere between a 1/16 and an 1/8 of an inch. That's all I'm using. This is a trash truck. Again, similar principle, very small hole on the outside of the trash truck. I've got a fire in there. Who knows? It could have been started by a very small lithium-ion battery. But again, it's just a small spot weld to get that vehicle back on the road in no time at all. Similar with a combine harvester on the right. Combine harvester is very expensive bit of kit. Farmer needs to get that back working as soon as he can. He's got a certain amount of time to get that field harvested. Again, small hole using Cobra lance just to pierce through and deal with that fire inside. This was an incident at Christie Hospital in Manchester about 7 years ago. Now at the hospital, they've got MRI scanner. Now on the MRI scanner, they've got about 5 years worth of cancer research data, which they couldn't afford to lose. Otherwise, they'd have lost 5 years worth of expensive data. This is an incident in Northamptonshire. Cobras across the whole fleet in Northamptonshire. They tried to get water onto the roof. It didn't work. Roofs are designed to hold water off. So they decided after a small period of time to use Cobra. And you can see the guys on the right-hand image. They actually used, I think, either 4 to 6 Cobra lances around the outside of that roof just to get water into that building. And very quickly, that fire was dealt with. So that was another successful use of Cobra in the UK. People often ask to us, because the hose generally comes as either 120 foot or 240 foot length, depending on which system you've got. But you can extend that hose, and you can pretty much extend that hose as much as you want. So this was the hose extended to over 1,100 feet. And at the time, this was the tallest building in Europe. We were cutting up on the 74th floor using 830 feet of hose. And it was still effective enough and still powerful enough to pierce through structural steel. And that's the hole there you can see. So we've cut through 3/4 inch of structural steel on the 74th floor using 830 feet of Cobra hose. That is me done, I think. So I'm going to try and get back into the presentation.
Well, I have to tell you, first of all, I need to apologize for my computer this morning. Fortunately, the people at our tech center answered the phone as soon as I called, and he helped me get back online. I don't know what happened. He doesn't know what happened, but we got it fixed. So we're going to go through. I'm going to start with the Q&A that we have right now. And some of these have been answered. I'm going to take the open ones right now. So the first question comes from Rich Chappie Bauer. Does the water escaping out of the batteries contain toxic elements needing hazmat intervention?
Can we take that one, Lena?
Yeah, please do that, and I can fill the gaps.
Yeah, so all vehicle fires, whether they be ICE vehicles or lithium-ion battery-powered vehicles, will contain toxic elements. I've been going to car fires for nearly 40 years now, and I'm embarrassed to say that in the old days, I used to put out car fires just holding my breath without any SCBA, because we didn't realise the toxicity of the gases and vapours being driven off from a car fire, and again, the water runoff from a car fire. Research has shown that there are very little differences between the water runoff from a lithium-ion powered vehicle to an ICE-powered vehicle. So yes, there are toxins there, but nothing in excess to what we would normally get in a normal vehicle fire. The difference is we're using significantly less water in an EV fire because we're using 7.5 to 15 gallons a minute instead of 400 to 500 gallons a minute. Anything to add on that, Lena?
No, I would say that's also, since we are flooding the battery pack, we will get some metallic and nasty stuff from that flooding. So obviously we need to collect the water, but I think that's like the regular thing to do with any runoff water from any incident.
Yeah.
But the amount of runoff water would be far less than it would be if we were using a typical 1 3/4 hose in the United States. So the water runoff, there's less to deal with, I guess is what I'm trying to say.
Yeah, agreed.
Okay, so Dave Grumney has a question. Is there a safety trigger, like the nozzle has to be pushed up against something, against your target before firing?
So there's a couple of safety features on the lance itself. There's one which we call a safety. And when we teach people, and last week or the week before in Oregon, some of the US firefighters were having a go with the lance. So I said, before you pick it up, make sure the safety is on. So there's a little button at the bottom of the lance. You pull the button down, which arms the lance. So before we pick it up, we just make sure the safety is on. So the lance is disarmed. When I pick the lance up, then there's a dead man switch, which I operate with my thumb. I can then operate the levers. But for our lance, you don't need to push it up against anything, which is why you can use it, for example, in the fresh air environment that I said for the cooling
So the safe,
yeah, thermal protection.
the safety that he's speaking of is in the trigger itself.
Absolutely, yeah, that's
Okay.
correct.
Similar to a nail gun in the US. Now, the difference is with a nail gun, you have to put the end of the nail gun against something to fire it. But this, all you need is the safety and the trigger, and it has a dead man switch on it.
Exactly that, Ed, yeah.
All right, great. From Jordan Davis, how large is the water stream coming out of the Cobra?
It's about 180 feet on a 15 gallon a minute unit, slightly less on the 7.5 gallon a minute. So it'll travel a long, long way.
Okay. And this was answered earlier during your presentation, but Walter May asked the question, what is the PSI used again?
Well, about 4,300.
And from Mike Roosevelt, did I catch you saying there are two triggers, one for water only and one for abrasive plus water?
Absolutely. So there are two triggers on the lance. One we can use just water. And if I'm piercing through UPVC or plastic window frames or a wooden door frame, I don't need abrasive. But with the use of abrasive, that's for the secondary trigger, that introduces that 5% abrasive to water mixture. So 5% abrasive, 95% water. And then that will pierce through any building material known to man. Once I've pierced through, either I stop seeing splashback or I see steam. I can then release the abrasive trigger, so I don't need abrasive anymore, and then just flow water into the other side of that, whatever I've pierced through.
Okay. And John, I'm not going to try to pronounce your last name. Is it a possibility that by using the system for a battery pack, you can pierce the good batteries, making the thermal runaway worse?
Absolutely, yeah. And we tried that. We tried it on purpose. We did some tests with Skoda, who make vehicles in the Czech Republic, and they were using salt water to get their batteries into thermal runaway, because lithium-ion batteries do not like salt water at all. So actually what they had the whole battery involved in thermal runaway, which is slightly extreme as a test. And they said to us, do you think we could use Cobra to excite one of the actual cells to get it to go into thermal runaway? And we said, yeah, let's try it. So we did it, and it did exactly that. It got it into thermal runaway, but then straight away, it put it out as well at the same time. So yes is the answer, but no, it didn't work.
Okay. So it did create the thermal runaway, but it put it out at the same time.
Absolutely, yeah.
Exactly. Richard Cherry, and the question is, how much does this cost in US dollars?
I'm going to hand it over to Martin Norman, who's in the background.
Oh, no, sorry, he's left.
He had to leave for something else. That's why we're going back through all the questions. He answered a lot of things when he was on, but he had to leave.
I think it's about $50,000.
All right, there you go. About $50,000.
That's not a quote. Don't hold me to that.
All right. For Jordan Davis, I think we answered this one before, but we'll answer it again. What's the pressure of the water that's coming out at?
4,300 PSI.
And to Scott, yes, you messed up on the timing. When we send out the email, you'll have a link for the recorded webinar along with a lot of other information. So that took care of everything that was open. I want to go back to some answers because some of them were answered privately. Here's one. What is the liability to the fire department that uses Cobra when manufacturers of EVs in the state and their response guides tell you not to pierce the battery pack? We had this conversation during our podcast, so this is a great question for the webinar.
I think you answered it good
You want to
last
say that
time.
one,
Carl.
Lena? Or you're taking that one?
You go ahead, Carl. You do it great. You go ahead.
Carl, where'd you go? It looks like he froze up.
You froze. So I'll guess I'll answer that one. So what Carl said, we're not mechanically piercing the battery, we are hydraulically piercing the battery. So, but we do not want to go against what the car manufacturer says. So it's up to each and every organization to make their routines clear and risk assess. This is one way to cool the battery or to stop the propagation. And this is our suggested method.
So are you making inroads because of what you're doing in Europe with the US car manufacturers? Are they starting to change their opinion on introducing water to lithium ion batteries in the US, since you've proven in Europe that it's a proven method?
I think it's a slow process, and it is. I'll be honest with you, it's work in progress. I know that the app that we use in the UK, Euro Rescue Data app, historically that said do not pierce the battery. Apart from some of the Skoda models which said introduce water into the battery pack using Cobra, what they generally say now is to stop propagation, get water into the battery pack. And that's what a lot of the rescue data sheets say. They don't tell you how to do that, but they tell you to get water into the battery pack. And I'm sure other manufacturers will eventually change their guidance once they realize some of the solutions that are out there.
Okay, so ultimately the question is, we just need to wait for the US car manufacturers to get on board, and I'm not quite sure how we do that. I don't know how I get to the big three in the United States and say, go to Europe and learn something.
If you find out, Ed, let us know.
Well, and to that point, we obviously you've sold a system, but Tempe's been using the system. I don't know if there are other U.S. fire departments that have purchased the system and have used it on EVs. So it is being used in the U.S. in spite of the fact that U.S. car manufacturers are saying don't pierce the battery pack. So that's a problem that's well beyond your control and my control. As you said, it may take a few years for that to happen.
Yeah.
So this one was, you said the excess water would be released through the built-in pressure relief holes or valves. What guarantees those valves are not damaged from the fire? And Martin answered that by saying we can cut new flow paths with the lance if needed.
Yeah, that's true. And also the fire will also pierce hole from inside, so it will be a leaking battery anyway, so it wouldn't hold any water.
Okay. We answered that one. Here's one. What prevents the lance from cutting fully through the battery compartment, thus draining the cooling water?
So
And
the short answer to that is training. So what we say to people to do when they're using the lance is to bring abrasive up to the lance, and then when they operate the lance, there'll be 120 feet of hose with abrasive in it. So all I'm going to do is I'm going to use the water trigger, not the abrasive trigger. That will then flush out the abrasive initially for the first few seconds, which is enough abrasive to pierce through the car floor, pierce through the top layer of the battery, and then flow water into the battery pack. If I do flow water into the battery pack and actually accidentally pierce through the bottom of the battery pack, again, that's not a deal breaker, because just like when you take the faucet, the plug out of your bathtub, it doesn't empty out instantly. It takes a while to empty out. So I'm still flowing water. Yes, I might be losing some water, but I'm losing less than I'm flowing in. So I'm still going to have that cooling effect, just not as efficiently. But training is the key aspect, really, to stop piercing through both top and bottom.
And that's a great lead into the next question. Can you provide training details, i.e. when and where trainings will be held? Do you have any scheduled here in the U.S. anytime in the near future?
Not that I'm aware of. We just did a couple of demonstrations in Oregon week before last. I know we're going out to Arizona again soon, but specific training detail, nothing planned at the moment. But we can certainly get back to you on that one once you've got more details.
Okay. The other thing that I'll offer to you is, if you get training scheduled in the U.S., if you want other people to be able to attend the training, if you want to open it up, I guess, if you let Sam and I know, we can help market it for you. If you wanted, now, obviously, if you're doing one for a particular fire department, they may not want others there, but if it's an open invitation, let us know and we'll help market it.
That's great. Thanks, Ed.
Mike Roosevelt asked the question, is the abrasive a slurry mix and does it have a shelf life?
Sorry, I didn't catch that.
The question is the abrasive a slurry mix and does it have a shelf life? I think the question is the abrasive material itself mixed with the liquid that it's stored in, and is there a shelf life, or is it's independent from any liquid?
Yeah, it's mixed with it's mixed with water in while you activate the trigger for abrasive. So that's when it mixes with the water. So
Okay.
before it's just a grain. Yeah.
So there is no shelf life on the abrasive itself.
No.
Okay.
Everlasting.
Nick Cadena says, would the authority having jurisdiction on piercing the battery procedures? Nick, my answer to that is you need to speak with your department leadership and see what their take on it is. If the leadership in your department looks at this training, decides to purchase a cold cut system, follow all, obviously, if you purchase one of the systems, you're going to get the training with it. So again, the authority having jurisdiction, you need to talk to your department leadership. To Richard Cherry, there'll be links in the email that we send out. His question is, how do I get information on how to purchase the setup? Those links will all be on the email that you receive, that you'll be able to pursue that. The comment was work with the NFPA. Have you had discussions with the National Fire Protection Association?
No, not regarding the EV.
Okay.
No.
All right. And then the other question is, are there any health concerns with the abrasive liquid?
No, not at all.
Okay.
It's not a liquid, first off, and then it's a natural occurring substance. It's a residue from the help me, Carl, with the English.
Steel industry.
Mineral industry. Thank you.
All
Yeah,
right.
yeah. It's actually totally environmentally friendly. I mean, it's not harmful to the environment or humans. It's just it's like an iron filing and sand mixture, really. That's the best way of describing it.
Okay, so there's a couple of comments in here. Was there any results from pressurized water being introduced to an electrical environment? I'm assuming you mean other. I'm going to assume he means other than an EV, a lithium-ion battery.
Yes, we've done some testing with pure water and then water with additives. And I don't have the full details, though the live object was 1 meter from the nozzle, and we did not have any elevated, we didn't have any, the current wasn't, the mist is not electrified by the,
Okay.
the
So
live
there was no electrical feedback to the mist.
Exactly, when it was pure water, I should say, but with additives, we had some elevated figures.
Okay. So I have a comment here. Do we know what fires Tempe is using the Cobra on, multi-use or only EV fires? Did they purchase multiple units?
So Tempe purchased 2 units initially, and I know they're looking at purchasing, I believe they're looking at purchasing more. Initially, they bought it for the EV solution, but as we rolled out the training to them, and whilst we were doing the training, we adapted that because they wanted to look at the wider use. And I know they've also used it on an attic fire as well as an EV fire. So they are looking at the wider use.
All right, there's a comment here. Piercing the battery cancels the car insurance. Well, if the car is on fire and it's in the battery, I can't argue with the insurance companies. If your insurance company says they're not going to pay for it, they're not going to pay for it. But the car is going to be destroyed one way or the other anyway.
We haven't always got the option to let them burn out, have we?
All right, I think we covered pretty much everything that was in the chat. Let me go back to the Q&A. Here's a good one. What about cold weather performance? No different than any cold weather performance with any other water product, I'm assuming.
Yeah, we have a winter mode on the Cobra. If the reason is that the water might freeze, we have a winter mode. We live in Sweden. It's manufactured from Sweden, so we do
Okay.
know cold weather.
All right. And I think I'm going to take the last one here. Will there be any information within the emails on how to get a demo of this product? Again, there'll be links in there that you can contact both Lena and Carl and the company itself. So you'll be able to get that kind of information. You'll be able to email them directly to be able to get that kind of information. If you have any trouble with that, all you got to do is let Sam and I know that you have a question and we can get the information to them as well. So I'm going, all right. So the only other thing was here, are there MSDS sheets to the handout? So you have any MSDS sheets for the, we're talking about water and the abrasive. Is there a material data safety sheet for the abrasive?
So we do have a material data safety sheet for the abrasive.
Okay. So if you could send that to us at some point here yet this morning, when we send our email out, I'll have Sam include that with the email that he sends. All right, folks, we're pretty much going to wrap up here now. And so look, I want to extend my heartfelt gratitude to you for sharing your expertise to our listeners. I'm confident that our listeners have gained some additional insights in dealing with lithium-ion batteries, vehicle fires, and other uses of the Cobra system. Now, I know some of you may say, boy, this was a great advertisement for coldcut. Yes, it was. But they also introduced those of us in the United States to some additional tools and tactics that we could consider in dealing with more than just lithium-ion batteries. Okay. So at the end of the day, that's what the whole purpose of this was to learn from our friends across the pond, if you will. Again, you'll have links in the emails that are sent to you that'll take you to the Coldcut Cobra website where you can explore additional information. There'll be a short survey at the conclusion of today's episode. Please take the time to complete it. You'll be getting your certificates for attending today. Also, the episode will be uploaded to our website, and you'll receive a link to that in the email today. Again, please check your spam or junk email before sending us an email saying you hadn't received anything, because it'll come from a Provident INS email address, so it may go to your spam. If you're going to use this training as a group of people, when you receive the thank you today for joining us, there'll be an Excel spreadsheet attached. Please use the spreadsheet to include the names and email addresses for the certificates. It makes it much easier for me when I'm doing the certificates. You can review all our previous webinars at www.providentins.com and then look for the training resources link. Join us on October the 29th at 7 p.m. We'll be doing a roundtable discussion with family survivors affected by first responder suicide. We'll have Joe Bonanno and Amy Gillen to join us as family survivors, and Abby Tidwell, a counselor from Behavioral Health Systems, join us. Again, I want to thank both Carl and Lena for their time today. It was a great presentation, and I'm hopeful that some of our, look, I'm going to make a commentary here that's not part of the script. I'm going to go off script for a minute. And Sam's sitting behind the scenes holding his eyes right now. When we did our podcast, when I did the podcast with the both of you, we talked about the number of line of duty deaths in the UK and in Sweden. And your numbers are substantially less than they are in the United States year after year. All I'm saying is I'm not trying to downgrade the U.S. Fire Service. All I'm saying is there's something for us to learn from what they're doing in Europe And if we use nothing else as the metric to measure it, take a look at the number of line of duty deaths year after year. And I think you'll see that they have far fewer line of duty deaths. And it has nothing to do specifically with the cold cut system. It's all the systems they have in place that we have been slow to adopt in the US. So all I'm saying to those of you from the US Fire Service, don't be afraid to take a look at what they're doing in Europe. If it saves one life in the United States, it was worth you spending the time that you took to do the research. So with having said all that, I'm going to conclude with what I always conclude with. Until we meet again, stay safe for your family's sake. And thank you for joining us.
Thank you.
Thank you.